Hello there. What we're going to be looking at in this video is doing mass conversions to kilograms, an issue that I see lots of students have across all grade levels. So, the issue that we're dealing with is quite often when we're doing any sort of a conversion that has a metric prefix, people will deal with it quite well if it's just a matter of swapping out the metric prefix for the associated scientific notation. That's great. But if we're dealing with masses, then we have to make sure that we are doing an additional step to get that mass converted into kilograms before we use it in the calculation. We can't be doing things afterwards. By then it's too late, potentially. So we need to make sure that we have it in kilograms, and then we go ahead and do the rest of our physics calculation. So the example that I'm going to do with you is where I'm working on a problem. I'm not saying what the physics problem is, but I'm doing a question and I'm told that the mass of the object I'm dealing with is 250 Ag. Now I specifically chose to do it from this Ag measurement because I know that's something that probably you haven't seen as often. But I gotta tell you, this isn't something that's supposed to freak us out, because we are used to certain measurements with metric prefixes. A lot of times, some of the first exposure we really get to metric prefixes that we see all the time are measurements of length or displacements. Things like centimeters and millimeters and kilometers. That's great. It's also not unusual to see measurements of masses in milligrams or kilograms, the thing that we actually want. But what we need to recognize is that any measurement in the metric system can be given with these metric prefixes, including metric prefixes that we're not as commonly seeing. That's because there's so many measurements that we do that are either for very large values, like the mass of a planet or the distance between stars. But there's also very small measurements we do, like mass of an electron or the energy of a single photon of light. So we have to get used to these other measurements that we could see as well. Metric units, or metric prefixes, I should say, can be used in front of any measurement that we do. It doesn't have to be just millimeters and milligrams. We can see those metric prefixes in front of anything. So I could have CN, centinewtons. I'm not saying that's something I would often see, but it is allowed. I can see things like MJ, millijoules. What I've got to recognize in all of these is that the second letter is the one I should be looking at for the unit of measurement that I probably am quite familiar with. And the first letter is going to be the metric prefix. And that means I should be referring to a data sheet to be able to figure out what that metric prefix means. So that's what I'm going to do for the example we're doing, where I have to figure out what 250 Ag means. I know the G is grams, but what's the A at the beginning? When I look at my data sheet, I can see that A is atto. And apparently atto is times 10 to the negative 18. So that means we're measuring a mass here that is really, really small. 250 Ag is 250 attograms. That's what it means to me. So right there, that gives me enough information to do what really is the first sort of conversion for me. That means that what I'm going to do is replace the metric prefix with scientific notation. So I was given the number 250 Ag, attograms. I'm going to replace that A, the atto, with its scientific notation, times 10 to the negative 18, because that's what atto means. Now, for those of you that are being particularly sharp about your rules of scientific notation, yeah, I know, I'm kind of breaking it here, or at least bending it a bunch. Because in scientific notation, I'm never supposed to put more than one non-zero digit in front of the decimal. And I just wrote down 250. That really shouldn't be allowed, at least not for a final answer. But what I'm going to say in defense of this is, I'm not even done yet. And also, whatever I'm going to get for a mass out of all of this is probably a number that I'm going to put into a formula, and I'm going to do another calculation with it anyways. It'll all sort out later. So for now, all I'm doing is just the direct replacement of atto with times 10 to the negative 18. And if this was anything other than a mass, this would be it. This means that this is now a number that I could start using in my formula to do another calculation. But because it is a mass, I can't leave it in grams. I need to get it into kilograms. So for that reason, I'm going to have to set up a ratio. And I love ratios because what I tell students is that whatever I put into a ratio, whatever I'm going to put into this bracket set that I've got here, is basically me saying whatever's on the top is equivalent to whatever's on the bottom. I sometimes say that whatever I put in those brackets has to be a truth, that I'm putting stuff in there that I'm saying the top is the bottom. They're basically measuring the same amount of something. So I know that for this particular question, I want to end up with kilograms. So that means I'm going to put kilograms on the top, 1 kilogram on the top. But then I have to put something on the bottom that is going to tell me what a kilogram is. I can look back at my metric prefixes and I can see there that kilo is times 10 to the 3. This is just like when I said atto is 10 to the negative 18. Well, kilo is 10 to the 3. So 1 kilogram is 1 times 10 to the 3 grams. The reason this setup of my ratio is so important is because kilograms is on the top, it's what I want to end up with, and grams is on the bottom, I can see that the grams in my original measurement and the grams on the bottom will basically cancel out. Grams over grams, they're gone. It means that what I'm going to be left with for a measurement is a measurement in kilograms. So on my calculator, and making sure that I'm using the proper scientific notation button, I'm going to put in 250 times 10 to the negative 18, well, times 1 really, but I don't really need to do that part, divided by 1 times 10 to the 3. The answer I'm going to get, and my calculator will move the decimal for something like this where it's dealing with a really small number, comes out as 2.50 times 10 to the negative 19 kilograms, because that's all I'm left with now for units. One last little note that I'll make about this number is that because the original number was given to me as 250 attograms, 250 had 3 sigdigs. So when I wrote my final answer here, even though my calculator might have just shown 2.5 times 10 to the negative 19, I put that 0 on there because I still want to show that I in no way have changed the number of sigdigs my number has by putting it through a conversion, because conversions can't change that. Usually at this point, I would now take this number, the 2.50 times 10 to the negative 19 kilograms, and I'd do whatever the actual physics problem is involving the mass. That's it. I hope this helps you out. Have a good day.